Representing our reporter for Week 1, Aiza May Takyawan.
Quarter 4, Week 1, Last 1. Antiderivative wave function. Terminologies and notation. Antidifferentiation is the process of finding the antiderivative. The symbol is called the integral sign. Denotes the operation of antidifferentiation. The function f is called integrand. If f is an antiderivative of f, we write integral sign f of x dx is equals to fx plus c. The symbol f and dx go hand in hand, and dx help us to identify the variable of integration. The expression f of x plus c is called the general antiderivative of f. Meanwhile, each antiderivative of f is called particular antiderivative of f. F of x equals 6 raised to the power of 5 minus x raised to the power of 4 plus 2x squared minus 3. In order for us to get the general antiderivative, we must first do the following. First, add 1 in the exponent, copy into the denominator so that will be fx equals to 6x raised to the power of 5 plus 1 over 5 plus 1 minus x raised to the power of 4 plus 1 over 4 plus 1 plus 2x raised to the power of 2 plus 1 over 2 plus 1 minus 3x plus c. Since 3 is a constant, all we need to do is add x. Next, add the exponent and denominator so that will be f of x is equals to 6x raised to the power of 6 over 6 minus x raised to the power of 5 over 5 plus 2x cubed over 3 minus 3x plus c, and lastly do the cancellation. It means our final answer is f of x is equals to x raised to the power of 6 minus x raised to the power of 5 over 5 plus 2x cubed over 3 minus 3x plus c, where c is an arbitrary constant. 2. F of x is equals to negative 3. Since negative 3 is a constant, all we need to do is to add x, and our final answer is negative 3x plus c. Number 3. G of x is equals to x cubed minus 3x squared plus 3x minus 1. As we did earlier, first we must add 1 to the exponent and copy it to the denominator. Do the cancellation to get the final answer. G of x equals x cubed minus 3x squared plus 3x minus 1 equals x raised to the power of 3 plus 1 over 3 plus 1 minus 3x raised to the power of 2 plus 1 over 2 plus 1 plus 3x raised to the power of 1 plus 1 over 1 plus 1 minus x plus c equals x raised to the power of 4 over 4 minus 3x cubed over 3 plus 3x squared over 2 minus x plus c equals x raised to the power of 4 over 4 minus x cubed plus 3x squared over 2 minus x plus c. X is equals to sine x plus cos x minus secant squared x. To solve these functions, we need to determine the antiderivative of this trigonometric function. Sin x is equals to cos x. The cos x is equals to sin x, and Negative secant squared x is equals to negative tan x. It means our final answer will be h of x is equals to cos x plus sin x minus tan x plus c. A function f is antiderivative of an interval I if f prime x is equals to f of x. The process of recovering a function f of x from its derivative f of x is called antidifferentiation. We use capital letters such as f to represent an antiderivative of a function f, g to represent an antiderivative of g, and so forth. Activity 1. F of x equals to 6x raised to the power of 5. In order for us to solve this function, we must first add 1 to the exponent and copy it to the denominator. So it should be f of x equals to 6x raised to the power of 5 plus 1 over 5 plus 1 plus c. Then add the exponent and denominator and do the cancellation. So it means f of x is equals to 6x raised to the power of 6 over 6 plus c. Cancel the 6, f of x is equals to x raised to the power of 6 plus c is our final answer where g of x equals to negative secant squared x. Trigonometric function negative secant squared x is we know that this equals to negative tan x. It means our final answer is g of x equals to negative tan x plus c. H of x is equals to 3x squared minus sin x. First, add 1 to the exponent and copy it to the denominator, and also solve the trigonometric function, which is the negative sin x. So that would be h of x equals to 3x raised to the power of 2 plus 1 over 2 plus 1 minus negative cos x. Because negative sin x is equals to negative cos x, then add the exponent and the denominator and convert the negative cos x to positive 1 because negative multiplied to negative is positive. So it should be h of x equals to 3x cubed over 3 plus cos x. Do the cancellation. H of x equals to x cubed plus cos x plus c. Our final answer.
For our reporter for week 2, Raymar Torrejas. Basic Calculus, week 2, last one. Definitions. The reverse of differentiating is anti-differentiating and the result is called antiderivative. The process of anti-differentiation is often called integration or indefinite integration. Basic integration rules. Integral of k dx is equals to kx plus c where k is a constant. Integral of x to the power of n dx is equals to x to the power of n plus 1 over n plus 1 plus c and n is not equal to negative 1 where c is any number. Scalar multiple. Integral of k f of x dx is equals to k integral of f of x dx. Splitting for addition and or subtraction. Integral of f of x positive negative g of x dx is equals to integral of f of x dx positive negative integral of gx dx. Activity. Find an antiderivative of in number 1, we need to first solve in the inner quantity, which is the x squared plus 1. So, x squared plus 1 multiplied by x squared plus 1 is equals to x to the fourth plus x squared plus 1 all over x to the fourth plus 2x squared plus 1. And then we need to go to the integration method, which is the integral of x to the fourth dx plus integral of 2x squared dx plus integral of 1 dx, and then x to the power of 4 plus 1 over 4 plus 1 plus 2x to the power of 2 plus 1 over 2 plus 1 plus x plus c. And our final answer is x to the fifth over 5 plus 2x cubed over 3 plus x plus c, where c is an arbitrary constant. In the problem number 2, we need to multiply the 2x cubed minus 7x squared plus 3x plus 4 into x. So, our answer is 2x to the fourth minus 7x cubed plus 3x squared plus 4x. Then we do the integration method. So, integral of 2x to the fourth dx minus integral of 7x cubed dx plus integral of 3x squared dx plus integral of 4x dx. And then we do the 2x to the power of 4 plus 1 over 4 plus 1 minus 7x 3 plus 1 over 3 plus 1 plus 3x to the power of 2 plus 1 over 2 plus 1 plus 4x to the power of 1 plus 1 over 1 plus 1 plus 3. Then 2x to the fifth over 5 minus 7x to the fourth over 4 plus 3x cubed over 3 plus 4x squared over 2 plus c. And our final answer is 2x to the fifth over 5 minus 7x to the fourth over 4 plus x cubed plus 2x squared plus c, where c is an arbitrary constant. In the problem number 3, all we need to do is to disseminate the denominator on each numerator. So, the integral of x cubed over 5x squared dx plus integral of x squared over 5x squared dx minus integral of 7 over 5x squared dx. Then, 1/5 integral x dx plus integral of 1/5 dx minus integral of 7 over 5 x to the power of negative 2 dx plus c. Then, 1/5 x dx plus 1/5 dx minus 7 over 5 x dx plus c. Then, we need to add the exponent as well as to copy it into the denominator. So, 1/5 multiplied by x to the power of 1 plus 1 over 1 plus 1 plus 1/5 x minus 7 over 5 multiplied by x to the power of negative 2 plus 1 all over negative 2 plus 1 plus c. So, 1/5 times x squared over 2 plus 1/5 x minus 7 over 5x plus c. So, our final answer is x squared over 10 plus x to the power x to the over 5 minus 7 over 5x plus c, where c is an arbitrary constant. In last two, there is an integration rules, which are integral of e to the power of u du is equals to e to the power of u plus c, and integral of au du is equals to au all over ln a plus c. Activity. Find an antiderivative of number 1. Number 1. Integral of 4 to the power of x dx. So, we need to identify the u and the du. So, our u is x and our du is equals to dx. So integral of 4 to the power of x dx. So in our formula, which is the integral of au du is equals to au all over lna plus c. Then, by doing substitution method, we can now get the integral of 4u du is equals to 4 to the power of u over ln 4 plus c. And our final answer is 4 to the power of x ln 4 plus c. Number 2, integral of 5x times 2x to the power of 3x squared dx. Then, we need to find the u and the du. Our u is equal to 3x squared and our du is equal to 6x dx, and divide each side by 6. So we can get the du over 6 is equal to x dx. So we need to do the integration rules. So 5 integral of 2 to the power of u du over 6 is equal to 5 over 6 integral of 2 to the power of u du plus c. Next, 5 over 6 multiply by 2 to the power of u over ln 2 plus c. So, 5 multiplied by 2, 3x squared all over 6ln plus c is our final answer. Or, we can also multiply rather the numerator, which is the 10 to the power of 3x squared over 6ln 2 plus c is also our final answer. 3. Integral of 2 multiplied by 3 to the power of 4x dx. So we need to find the u and the du. So our u is 4x and our du is 4dx. We can also simply do it our du by doing the cancellation. So du over 2 is equal to 2 dx, 2 over 2. So cancel the 2. So the remaining given are du over 2 is equals to 2 dx. So by the guide of the formula, which is the integral of au over ln a plus c, we do the substitution method. So integral of 3u quantity du over 2 is equals to 1 half times 3u over ln 3 plus c. So we need to substitute the u into 4x. So 1 half times 3 to the power of 4x plus ln plus 3. So our final answer is 3 to the power of 4x over 2 ln plus c, where c is an arbitrary constant. In the last three, we do also have the integration rules, which are the integral of x to the power of n dx is equals to x to the power of n plus 1 over n plus 1 plus c. Integral of cos x dx is equals to sin x plus c. Integral of sin x dx is equals to negative cos x plus c. Integral of secant squared x dx is equals to tan x plus c. Integral of secant x tan x dx is equals to secant x plus c. Integral of cosecant squared x dx is equals to negative cotangent x plus c. Integral of cosecant x cotangent x dx is equals to negative cosecant x plus c. Number 1. Integral of sine x all over 1 minus sine squared x dx. So, all we need to do is to rewrite it into integral of sine x over cosine squared times 1 over x is equals to sine x all over cosine x times 1 over cos x. So, the integral of sine x over cos x is also equals to tan x. So, the next step is equals to integral of tan x multiplied by 1 over cos x. So, we can get the integral of tan x secant x dx. So, this tan x and secant x, the integration of this trigonometric function is secant x plus c is our final answer. In the problem number 2, this is just quite simple. So, integral of quantity 2 secant squared x plus cosine x quantity dx. So, our final answer would be 2 tan x plus sin x plus c, where c is an arbitrary constant. Number 3, integral of x cubed minus sin x dx. So we need to do first the integration method. So integral of x to the power of 3 plus 1 over 3 plus 1 minus quantity negative cosine x plus c. So negative multiplied by negative would become positive. So our final answer would be x to the power of 4 over 4 plus cosine x plus c is our final answer, and c is an arbitrary constant. Week 2, last 4. The substitution rule. Integration by substitution. Most difficult piece of integration can be solved using integration by changing the variable and the integral. Suppose we are given an integral of the form integral f of g of x multiplied by g prime x dx. We can transform this into another form by changing the independent variable x to u using the substitution u is equals to g of x in case du over dx is equals to g prime x dx. Therefore, integral of f of g of x g prime x dx is equals to integral of f u du. This change of variable is one of the most important tools available to us. This technique is called integration by substitution or substitution rule. Activity. Compute the following integrals using substitution rule. Number 1. Integral of x plus 10 to the power of 9 dx. First, we must find the u. So our u is x plus 10. So we do the integration method. So integral of quantity x plus 10 to the power of 9 dx equals to integral of u to the power of 9 du. So integral of u to the power of 9 du is equals to u to the power of 9 plus 1 all over 9 plus 1 u. So it's equals to u to the power of 9 plus 1 is equals to 10 all over 10 plus c. So next is integral of quantity x plus 10 to the power of 9 dx. Dx is equals to integral of u to the power of 9 du is equals to u to the power of 10 all over 10 plus c. So let's do the substitution method. So our u is equal to x plus 10. So our final answer would be quantity x plus 10 to the power of 10 all over 10 plus c. So, number 2. Integral of quantity x plus 1 all to the power of 100. So our u is equal to x plus 1. Integral of quantity x plus 1 to the power of 100 dx is equal to integral of u to the power of 100 du. Next is integral of u to the power of 100 du is equals to u to the power of 100 plus 1 all over 100 plus 1 plus c. So 100 plus 1 is equals to 101. So next is u to the power of 101 all over 101 plus c. So integral of quantity x plus 1 to the power of 100 dx is equals to integral of u to the power of 100 du is equals to u to the power of 101 all over 101. So let's do the substitution process, which is the u is equals to x plus 1. So our final answer will be quantity x plus 1 to the power of 101 all over 101 plus c, where c is an arbitrary constant. Number 3. Integral of 3 plus y squared to the power of 10y dy. First, we need to identify the u and the du. So our u is equals to 3 plus y squared, and our du is equals to y plus 1 all over 1 plus 1. Du is equals to y squared over 2, and our y squared is equals to du over 2. This du over 2 is also 1 half. Next is integral of 3 plus y squared to the power of 10 y dy is equals to integral of u to the power of 10 du. Next, integral of u to the power of 10 du is equals to 2 equals to u to the power of 10 plus 1 all over 10 plus 1 plus c. So 10 plus 1 is equals to 11. So it is equals to u to the power of 11 over 11 plus c. Next is 1 half. 1 half comes from the d over 2. So 1 half multiplied by quantity 3 plus y squared over 11, power of 11, all over 11 plus c. So our final answer, and by doing the substitution method, our final answer will be quantity 3 plus y squared over 11, to the power of 11, all over 22 plus c. 22 comes from the 2 multiplied by 11, which is denominator multiplied by denominator, where c is arbitrary constant. Number 4. Integral of the quantity x squared plus x to the power of 10, quantity 2x plus 1 dx. So we need to find the u and the du, and our u is equals to x squared plus x, and our du is equals to 2x plus 1 dx. Comes from the derivative of u is equals to x squared plus x is 2x plus 1. So the next step is by doing the the integration method. So integral of quantity x squared plus x to the power of 10 dx is equals to integral of u to the power of 10 du. Integral of u to the power of 10 du is equals to u to the power of 10 plus 1 all over 10 plus 1 plus c. And 10 plus 1 is equals to 11. So it is equals to u to the power of 11 all over 11 plus c. Then integral of x squared plus x to the power of 10 dx is equals to integral of u du is equals to u to the power of 11 over 11 plus c. So our final answer by doing the substitution method, which is the u is equals to x squared plus c, which is the quantity x squared plus x to the power of 11 all over 11 plus c, where c is an arbitrary constant. Number 5. Integral of 1 minus x squared to the power of 3 dx. So our u is equals to 1 minus x squared, and our du is equals to x to the power of 1 plus 1 over 1 plus 1 dx. Du is equals to x squared over 2, and our dx is equals to du over 2 over the 1 half. So integral of quantity 1 minus x squared dx is equals to integral of u to the power of 3 du. So integral of u to the power of 3 du over 2 is equals to u 3 plus to the power of 3 plus 1, all over 3 plus 1 plus c. And 3 plus 1 is equals to 4, so the next value is equals to u to the power of 4 all over 4 plus c. Then 1 half multiplied by quantity 1 minus x squared to the power of 4 plus c all over 4. 1 half comes from the d over 2. So our final answer by doing the substitution method, so quantity 1 minus x squared to the power of 4 all over 8 plus c. 8 comes from the multiplying the two denominators, which are the 2 and 4. So in the week 2 last 5, we also have the integration by substitution. Integration by substitution, or the substitution rule, is applicable also in some integrations containing radical expression. If we have a radical expression f of g of x with its derivative g x dx, then integral of f of g x dx is equals to integral of f of u du. Activity. Compute the following integrals using substitution rule. Number 1. Integral of x all over square root of x 2 minus 1 dx. So our u is equal to x to the power of 2 minus 1 or x because 2 minus 1 is equals to 1 and x is already have an exponent of 1. So it's equals to integral of x to the power of square root of x 2 minus 1 dx is equals to integral of 1 all over square root of u multiplied by 1 half du is equals to integral of 1 to the power of u to the power of 1 half multiplied by 1 half du is equals to 1 half integral of u to the power of negative 1 half du is equals to 1 half integral of u to the power of negative 1 half du is equals to 1 half multiplied by the u to the power of 1 half all over 1 half plus 1 half quantity u to the power of 1 half all over 1 half plus c is equals to 1 half plus c. So next step is by doing the substitution. So quantity x 2 minus 1 all over 1 half plus c or x to the power of 1 half plus c is our final answer for the R. Number 2. Integral of x cubed all over square root of 1 minus x to the 4 dx. U is equals to 1 minus x to the 4 is equals to x cubed all over square root of 1 minus x to the 4 dx is equals to integral of 1 all over square root of 4 u minus 1/4 du is equals to integral of 1 all over u to the power of 1 half minus 1/4 du is equals to negative 1/4 integral of u to the power of negative 1 half du is equals to negative 1/4 integral of u negative 1 half du is equals to negative 1/4 quantity u to the power of 1 half all over 1 half plus c is equals to negative 1/4 quantity u to the power of 1 half all over 1 half plus c is equals to negative 1 half. Why it is negative 1 half? Because when we multiply the negative 1/4 and the 1 half, we will get the negative 1 half. So, is equals to negative 1 half quantity u to the power of 1 half plus c. So, our final answer by doing the substitution method, which is the u is equals to 1 minus x to the power of 4. So, it is equals to negative 1 half quantity 1 minus x to the 4th to the power of 1 half plus c, where c is an arbitrary constant. Number 3. Integral of x cubed all over the square root of x cubed plus 5 dx. First, we need to find the u. So our u is equals to x cubed plus 5 is equals to x cubed all over square root of x cubed plus 5 dx is equals to integral of 1 all over square root of u multiplied by 1/3 du is equals to integral of 1 all over u to the power of 1 half multiplied by 1/3 du is equals to 1/3 integral u to the power of negative 1 half du. So, 1/3 integral of u to the power of negative 1 half du is equals to 1/3 integral of quantity u to the power of 1 half all over 1 half plus c is equals to 1/3 to the power of quantity u to the power of 1 half all over 1 half plus c is equals to 2/3. Where do I get the 2/3? So we will just going to multiply the 1/3 into 1 half. So we just going to shift the to reciprocal the 1 half and multiply it straight. So 1 times 2 is equals to 2 and 3 times 1 is equals to 3. So that's why we get the 2/3. Now to the following steps. So 2/3 quantity u to the power of 1 half plus c. So our final answer by doing the substitution method is equals to 2/3 quantity x plus 5 to the power of 1 half plus c. Week 2, last week, the substitution rules. Integration by substitution. The substitution rule is also applicable in trigonometric functions. Let's remember the following integrals. Number 1, integral of sine x dx is equal to negative cosine x plus c. Number 2, integral sine of cos x dx is equals to sine x plus c. Number 3, integral of secant squared x dx is equals to tan x plus c. Number 4, integral of cosecant squared x dx is equals to negative cotangent x plus c. Number 5, integral of secant x tan x dx is equals to secant x plus c. And lastly, number 6, integral of cosecant x cotangent x dx is equals to negative cosecant x plus c, where c is an arbitrary constant. Activity. Compute the following integrals using substitution rule. Number 1. Integral of negative cosine x sine x dx. First, we need to find the u and the du. So our u is equal to negative cosine x and our du is equal to sine x dx. So, integral of negative cosine x sine x dx is equals to integral of u du is equals to u squared over 2 plus c. Next is by substitution method and the integration method. So, integral of u squared all over 2 plus c is equals to negative cosine squared all over 2 plus c, where c is an arbitrary constant. Number 2, secant x cosecant x dx. Our u is equals to secant x and our du is equals to cosecant x. So, integral of secant x cosecant x dx is equals to integral of u du is equals to u squared all over u 2 plus c is equals to integral of u squared over 2 plus c is equals to our u is equals to secant x, so our numerator would be secant squared x all over 2 plus c, or in the integration rule, the secant squared x is equals to tan x. So our also answer, I mean the final answer would be tan x over 2 plus c. In the problem number 3, I have two solutions. First is integral of 2x over square root of 4x squared minus x squared dx. Integral of du all over a squared minus u squared is equals to sine negative 1 quantity u over a plus c. Integral of 2x all over square root of 4x squared minus x squared dx is equals to 2x all over square root of 2 squared x squared minus x squared plus c. So our final answer is sine negative 1 quantity x over 2 plus c, or integral of 2x all over square root of 4x squared minus x squared dx is equals to 2x all over 3x squared dx. U and our u is equals to 3x squared. So 3x squared comes from 4x squared minus x squared. So integral of 1 all over square root of u multiplied by 1/3 du is equals to integral of 1 all over u to the power of 1/2 multiplied by 1/3 du is equals to 1/3 quantity u to the power of 1/2 all over 1/2 plus c is equals to 1/3 quantity u to the power of 1/2 all over 1/2 plus c is equals to 2/3 quantity u to the power of 1/2. So our final answer is 2/3 quantity 3x squared plus 1/2 plus c by doing the substitution method, and and c is C is an arbitrary constant.
Quarter 4, Week 3, Application of Anti-Differentiation to Differential Equation. Separable equation is said to be separable of the variables can be separated. That is, a separable equation is one that can be written in the form f quantity y dy equals g quantity x dx. Once this is done, all that is needed to solve the equation is to integrate both sides. The methods for solving separable equation can therefore be summarized as follows. Separate the variables and integrate. Activity number 1. Solve the equation 2y dy equals quantity x squared plus 4dx. As we can see in the equation, it is already been separated. First, we need to integrate both sides. So that means integral of 2y dy equals integral quantity x squared plus 4 dx. Then, add 1 in the exponent and copy to the denominator. That means 2y to the power of 1 plus 1 over 1 plus 1 plus c1 equals x to the power of 1 plus 1 over 1 plus 1 plus 4x plus c2, and lastly, add the exponent and denominator and do the cancellation to get the final answer. So it should be equals 2y squared over 2 plus c1 equals x squared over 2 plus 4x plus c2 equals y squared equals x squared over 2 plus 4x plus c, where c is the arbitrary constant. Number 2. Solve the equation y quantity 3 plus x squared y prime minus x quantity 2 plus y squared equals 0. As we can see in the equation, there is a y prime, and that y prime is equals to dy over dx. So we have y quantity 3 plus x squared dy over dx minus x quantity 2 plus y squared equals 0. Then, let's do the separation method, and that would be y quantity 3 plus x squared dy over dx equals x quantity 2 plus y squared. Next, separate the x's and y's, so it means y over 2 plus y squared dy equals x over 3 plus x squared dx. Then, integrate both sides. Integral of y over 2 plus y squared dy equals x over 3 plus x squared dx. In order for us to find the integration of this function, follow the integration rules. Means u equals 2 plus y squared, du equals 2y dy, or du over 2 equals y dy. Then, 1 half integral 1 over u du, and the integral of 1 over u is ln quantity u. So 1 half ln quantity u plus c1, and our u equals 2 plus y squared. So our answer will be 1 half ln quantity 2 plus y squared plus c1, the same method in the other side, and we will able to get 1 half ln quantity 3 plus x squared plus c2 from x over 3 plus x squared dx. It means our final answer is 1 half ln quantity 2 plus y squared equals 1 half ln quantity 3 plus x squared plus c, where c is an arbitrary constant. Number 3. Solve the equation dy over dx equals negative x over y. In this equation, we have to separate the x's and y's, so that would be negative y dy equals negative x dx. Then do the integration process. Integral of negative y dy equals integral of negative x dx. Add 1 to the exponent and equals negative y to the power 1 plus 1 over 1 plus 1 dy equals negative x to the power 1 plus 1 over 1 plus 1 dx. Add the exponent and denominator equals to negative y squared over 2 dy plus 4 equals negative x squared over 2 dx plus c2. So our final answer is negative y squared over 2 equals negative x squared over 2 plus c, where c is an arbitrary constant. Activity number 1, solve the equation dy over dx equals y cos x over 1 plus y squared. We just need to separate the x's and y's both sides. So that means 1 plus y squared dy equals y cos x dx. And to cancel the y in cos x dx, we need to divide both sides in y. That means 1 plus y squared over y dy equals y cos x dx over y. Cancel the y, and that means 1 plus y squared over y dy equals cos x dx, and do the integration method. Since the y can be cancelled in 1 plus y squared over y dy, so our dy is 1 plus y dy equals to integral of 1 plus y dy equals integral of cos x dx. Add 1 to the exponent and copy to the denominator, and in cos x, convert it into sin x. So our answer is y plus y to the power 1 plus 1 over 1 plus 1 dy equals sin x dx. Add the exponent and denominator, y plus y squared over 2 plus c1 equals sin x plus c2. It means our final answer will be y plus y squared over 2 equals sin x plus c. Sin cube x cos x quantity 1 minus sin y squared dx minus cos y dy equals 0. We need to separate the x's and y's in both sides. So, sin cube x cos x quantity 1 minus sin y squared dx equals cos y dx. Then, to cancel the quantity 1 minus sin y squared on the left, we need to divide it both sides. It means sin cube x cos x quantity 1 minus sin y squared over 1 minus sin y squared dx equals cos x plus 1 minus sin y squared dy. Then do the cancellation. So, sin cube x cos x dx equals cos x plus 1 minus sin y squared dy. Then, integrate both sides. It means equals integral of sin cube x cos x dx equals integral of cos y plus integral of 1 minus sin y squared dy equals 1 over 4 sin to the power of 4x plus c1 equals sin y plus 1 negative quantity cos y squared, and equals to 1 over 4 sin to the power of 4x plus c1 equals sin y plus cos y squared plus c2, and equals to 1 over 4 sin to the power of 4x equals sin y plus cos y squared plus c. Is our final answer, where c is an arbitrary constant. Number 3. Solve the equation of dy over dx equals cos quantity 2x. Separate the x's and y's, and we can now get that dy equals cos quantity 2x dx. Then, integrate it, and it means dy equals integral of cos quantity 2x dx is equals to y equals 1 half integral of sin 2x plus c. Is our final answer.
And lastly, in week 4, we have Raymar Torrejas, our reporter. Basic Calculus, Quarter 4, Week 4, Last 1. Exponential growth. Exponential growth occurs when a certain quantity increases by the same rate r in each period of time. When this happens, the value of the quantity at any given time can be calculated as a function of the rate r and the original amount a. Common example of exponential growth is the compound interest. If we recall, compound interest is calculated on both principal amount and the previous earned interest. An exponential growth function has a form y is equals to a quantity 1 plus r to the power of t, where a is greater than 0 and y is equals to final amount, a is equals to original amount, r is equals to rate of growth expressed as decimal, and t is a time or period. Activity. Solve the given situation. The original value of sculpture is number 1. The original value of sculpture is 250,000 and the value increases by 5% each year. Write an exponential growth function to model this situation and find the value of 20 years. First, we must identify each values of the corresponding exponential growth of the function. Y is equals to question mark or the final amount, A is equals to 250,000 or the original amount, R is equals to 5% or 0.05, and that is our rate, and our T is equals to 20 years or the time or period. To solve this problem, we need to substitute the given into formula where y is equals to a quantity 1 plus r to the power of t, then do the substitution method, or y is equals to 250,000 quantity y plus 0.05 to the power of 20 is our exponential growth function. And by doing the PEMDAS rule, we can now get the answer, which is the y is equals to 663,324.43 or 663,324. Therefore, the value of the sculpture after 20 years is 663,324 pesos. Number 2. A certain bacteria multiplies every 10 minutes at a growth rate of 2%. If there are 200 initial population, how many bacteria are there after 2 hours? First, we need to identify the corresponding values of exponential growth function. Y is equals to question mark or the final function, A is equals to 200 or the original amount, R is equals to 2% or 0.02 or the rate, T is equals to 12 or the time, because 2 hours divided by 10 minutes is equals to 12 minutes. Then we can do now the substitution method. Y is equals to A is equals to quantity 1 plus r to the power of t is our formula. Then by doing the substitution, y is equals to 200 quantity 1 plus 0.02 to the power of 12. By doing the PEMDAS rule, we can easily get the final answer, which is the y is equals to 253.65 or y is equals to 254. Therefore, the bacteria after 2 hours is 254 bacteria. Week 4 last 2. Exponential decay. Exponential decay occurs when a quantity decreases by the same rate r in each time of period t. Just like exponential growth, the value of the quantity at any given time can be calculated by using the rate of the original amount. An exponential decay function has a form y is equals to a quantity 1 minus r to the power of t, where a is greater than 0 and y is equals to final amount, a is equals to original amount, r is equals to rate of growth expressed as decimal, and t is equals to time or period. A common applicable of exponential decay is half-life. The half-life of a substance is the time it takes for one half of one substance to decay into another substances. Activity. Solve the given situation. Number Number 1. The fish population in a pond is decreasing at the rate of 3.7% per year. The original population was 13,000. Write an exponential decay function to model this situation, then find the population after 10 years. First, we need to identify the given values of the function. Y is equals to question mark or the final function, A is equals to 13,000 or the original amount, R is equals to 3.7% or 0.037 or the rate, and our T is equals to 10 years. We can now do the substitution method and get the final answer, where Y is equals to A, quantity 1 minus R to the power of T, Y is equals to 13,000, quantity 1 minus 0.037 to the power of 10, and this is our exponential function decay. And by doing the PEMDAS, our final answer is y is equals to 8,000 rather 8,916.74 or 8,917. Therefore, the population of the fish after 10 years is about 800 8,917 population. Number 2. A certain bacteria multiplies every 10 minutes at a growth rate of 2%. If there are 200 initial population, how many bacteria are there after 2 hours? In this problem, it is just the same problem as last one, number 2, but this is an exponential decay function. We need to get the given, then do the substitution method. That means y is equals to question mark or the final amount, a is equals to 200 or the original amount, r is equals to 2% or the 0.02 or the rate, and t is equals to 12 minutes because when we divide 2 hours into 10 minutes, we can get the 12 minutes as the formula given where y is equals to a quantity 1 minus r to the power of t, y is equals to 200, quantity 1 minus 0.02 to the power of 12, and by using PEMDAS rule, we can get the y is equals to 156.94 or y is equals to 157. Therefore, the bacteria after 2 hours is 157 bacteria.